Hello, everybody. Welcome to another episode of Two Bald Nerds. I'm here with Mike Myers.
Hey,
And we
Richard,
are
good to
going
see you again, my brother.
Hey, good to see you too, man. We're going to talk about DNS today, right?
Yay!
DNS.
Hey, man, I'm
I know-
sorry. I'm a nerd. I like this kind of stuff. DNS is absolutely fascinating to me. It is the most core protocol of the internet. It's one of the oldest protocol. Well, I won't say that. There were things that preceded DNS, the internet of your forefathers, Richard. But DNS is really a critical tool, and it's an area that gets exposed to vulnerability, and you really got to know it.
Yeah, well, you know, our current cohort, they're learning a lot of Security Plus topics right now, and learning ports and protocols is definitely an important part of it. And, you know, we've mentioned DNS in the past, but we can really kind of only touch the surface on DNS. And I know there's many different levels to DNS. So I thought we would spend that time today kind of getting maybe a little deeper than we got before. I think a lot of people understand what DNS is, right? Kind of like a phone book for the internet, but that doesn't give all the details, does it? It's not even close, is it?
Well, I mean, it's a fun little analogy to when you want to do the 10,000 foot training, but
Right.
if you really want to start putting a screwdriver to DNS, we got to take it a little bit deeper. So for me, the most important thing to understand about DNS is that human beings are terrible at memorizing numbers. We're awful at it. Individual hosts out on the internet are identified by IPv4 or IPv6 addresses, right?
Yep.
But humans can't remember that my IPv6 address, I know mine, Richard, mine's 2002.143.1:14:295:3261.
You made
Today.
that up. You made that up.
I completely made that up, but it's a legitimate IPv6 address. So anyway, the idea behind DNS is simply to be able to use fully qualified domain names, FQDNs, with names like www.cybernowlabs.com. And I know we always talk about www as web pages, but DNS goes way past that. If you want to get your mail, I'll bet dollars to donuts that there's probably a server out there called mail.cybernowlabs.com, right? And if you use an FTP, there's probably an FTP. In fact, this one's still out there, ftp.microsoft.com I use for downloading. So it's a more human way to identify individual systems than trying to identify them simply by their IP address.
So definitely a lot deeper than just domain name service. I mean, there's a lot more to it.
Yeah, well, there is, but let's go ahead and knock out some of the big ones today. Folks, these are the most basic understanding that you need to understand DNS. So Richard, I'm going to start pontificating here. Feel free to just stop me at any moment. All right, so the bottom line is that your computer does not know the IP address of www.cybernowlabs.com. So what it does instead, and every computer set up with this, it might be set up statically, it might be set up with DHCP, but every computer has at least one, if not two, three, sometimes four DNS servers. The reason it has more than one, in case one's down, it can fall over to the next one. So somewhere out in the universe is your DNS server. For a lot of us folks, especially like someone at home, that's probably something administered by your internet service provider. And that's downloaded to you through DHCP, but it's always going to be there. When you go to www.cybernowlabs.com and hit enter, look in the lower left-hand corner of your web browser. You can actually see where it'll say attempting to resolve and that type of thing. And what you're looking at is it's talking to the DNS server. So the first thing your web browser does is your web browser goes to your operating system, because most operating systems, Windows, Linux, Mac, all have little DNS caches built into them. Look, you probably looked up cybernowlabs.com before. There's a good chance. Why go through all this DNS stuff if we can just keep a copy locally? If it isn't in there, it's going to talk to your DNS server. Your DNS server also has a cache. And if he doesn't know where it is, every DNS server has its own DNS server. So at a certain point, that DNS server is going to go up to what we call the root servers. Across the world, there are clusters, about 14 clusters. I haven't counted recently, 14 clusters with their own set IP addresses. And some of these IP addresses are 30 years old that are the root servers. And your DNS server, this is why you're sitting there watching where it says attempting to resolve, because your DNS server goes to the great root server in the sky and says, great root server, I need the IP address for www.cybernowlabs.com. And the root server goes, I don't know what that is, but I can get you to the .com servers. So scattered all over the world are about 100 to 150 different clusters of computers. And Richard, the only thing these things do all day is resolve DNS names. They're not running Microsoft Word on these things, okay? And so then these DNS servers, your DNS server goes to the .com servers and says, oh, great, .com servers. What is the IP address for www.cybernowlabs.com? And the .com servers go, we don't know, but I can get you to cybernowlabs.com server. And that's usually your DNS server, usually one you control, not always. And then your DNS server, your local one goes up to the cybernowlabs.com DNS server and says, oh, great, cybernowlabs.com server. Who's www? And he has the answer. So DNS resolutions like this happen all the time. And if you want to pass Security Plus, make sure you know that a DNS server's primary function is, ready, to resolve FQDNs, fully qualified domain names, to IP addresses. That's all they do all day long. So what I'd like to do, if it's okay with you, Richard, is I've actually got a DNS server up and running right now.
Yeah, while you're pulling that up, just little side notes. DNS port 53, right?
Yep.
UDP traffic, TCP traffic.
TCP.
Yeah. Okay.
There is some examples for UDP, but they're strange, and it's actually often it's security stuff, which will go that direction, but it's usually TCP port 53. All right, so let me bring this up for you so you can see this. All right, so what you're looking at is a local DNS server that I have set up here at the studio. And if you take a look right here, Richard, the name of my domain is called mictest.local. That's really important because a lot of DNS servers, they're really not designed to be on the internet per se. And all he's doing is handling my DNS request for my many computers and my IoT devices and my printers, because yeah, those devices need DNS too. So if we open this guy up, you can actually see inside of it, and you can see these different types of records. Now, a term I want to get into your head right away is, do you see the word forward lookup zone?
I was going to ask you that because you mentioned that last time we talked about DNS, you mentioned forward lookup zones and reverse lookup zone.
So a forward lookup zone is the primary workhorse of any DNS server. Every different domain has its own forward lookup zone. Keep in mind, a DNS server, in this case, he's only supporting mictest.local, but I could easily make a DNS server that supports 200 domains if I want. It's just a matter of how hard I want it to work. Reverse lookup zones. So a forward lookup zone resolves fully qualified domain names to IP addresses. Reverse lookup zones do exactly the opposite. They resolve IP addresses to fully qualified domain names. Reverse lookup zones aren't used very often. So let's first concentrate on forward lookup zones. So you take a look here, it says mictest.local. And we open this up. What I want you to see, now Microsoft Windows is notorious for adding a lot of gobbledygook. If we did this on a Linux machine, it'd probably just be a text file. So what I want you to look at here is we have, in this particular case, I only have 2 different hosts on here. So as far as this DNS server is concerned, I only have 2 computers on this network. And you'll see do you see the A record? A is an apple.
Yeah. Yep.
An A record is the standard #1 type of record. So what I'm going to do is I'm going to create a record. Let's pretend that I'm setting up a web server, and this web server is going to be www.totaltest.local. So I'm going to set up a new host, and I'm going to use the name www, because I don't need to type the rest in because it already knows. And if you look closely, it says www.mictest.local, and I'll type in some IP address. By the way, viewers, all these IP addresses are bogus, so don't try to hack me. All right. And it says it wants to create a pointer record. It might pop me an error. But what I've done here, let me add that one. Yeah, that's all right. So I'm going to close that. And if you take a look, I've now created an A record for www.totaltest.local. Notice I had to manually type in the IP address. Usually with servers, you manually type in the address unless you got some real super duper maintenance type of tool. but that's where these records come from. I know the IP address of the server I installed the web server on. Does that make sense?
Yeah.
So that's how I do that. People are like, where did this magic number come from? And it's like, well, because I set up the network, and that's how this stuff works.
Right.
If I want to, I can also set up a IPv6 quadruple A record. Quadruple A records are it's the same thing as an A or a host. It's just for IPv6. So
Okay.
Richard, what I want you to do is look right at the top here, because this is important. The one thing you got to remember about DNS, can you imagine that www.google.com only having one DNS server to handle all of that?
Yeah.
That's
Not really.
crazy. Right.
Yeah.
So what you'll do is on bigger domains, or anything bigger than a small test domain like this, is you tend to have a number of DNS servers. However, only one DNS server is the start of authority, only one. And if you open this up, you'll see there's a lot of interesting information in here. But what's important is that you'll see it's all of its information is here. It tells us what the actual name of the server it is itself, which is right here. Now you'll notice there's not an IP address in here. That's because he has his own A record, okay? So that's not where the IP address goes. You also have an increment. Every time a new record is added, this increment goes up. And that's how multiple DNS servers can talk to each other. They'll sit there and say, hey, I've incremented, which is a cue to the other name servers on my network to say, hey, wait a minute, maybe I need to update my forward lookup zone because, name server number 45 over here got an update. Does that make sense?
Yeah, very much.
Okay, so you can see this is the actual IP address for the name server. So in this particular little forward lookup zone, the start of authority or the SOA record also has an NS record with it. So that's always going to happen. Now, if I wanted to, I could add more. Let's say I'm going to add another DNS server because I got so many people trying to hit www.mytest.local that I need more DNS resolution. So I can just go in here and I can type in, make up anything I want here. So what's interesting is as I type this in, notice I don't even have to be on the same computer. I could have a DNS server up in the cloud. Get the idea?
Yeah.
So I'm going to put in we're going to pretend this guy doesn't exist. So we might get one of those fun errors, but I can't click on resolve because he doesn't actually exist. And Windows, yeah, whatever. And what's happening here is Windows wants to go ahead and double check me. He wants to go and find fred.totaltest.local. Get the idea?
Yeah, absolutely.
But otherwise, once it validates, it would come back because he would do an ARP record. He'd get the IP address and we could add more name servers. So so we now know what an SOA record is. Every forward lookup zone is going to have one SOA, the name server. You're going to have a minimum of one, but if you want more, because you have more DNS servers that are supporting that particular forward lookup zone, you can put more in if you want. Just make sure you have a DNS server. You're going to get the error I have. The last thing I want to do is I want to talk about some of the other records you run into. Because
I was just about to ask one of the other records I was going to ask you to mention is the pointer record, right?
Well, that pointer record is for a reverse lookup zone. So I'm going to do that next.
Okay.
But first of all, you also have what's known as canonical name. Canonical name is just like a lot of times it's easy to call a computer two different names. So if I want to call, I got www.totaltest.local. And what I can do instead is so you see what I've done here is I've got www2. So if somebody types in www2.totaltest.local, it will point them to www.totaltest.local. Get the idea?
I see, yeah.
Okay, so that's a canonical name. And the other one, and this was so important in security, is mail exchanger. SMTP uses DNS to get mail to the right computers. So if you have a mail server that's associated, and if you have people with the email address of totaltest.local, you got to have a mail exchanger in there. And so you have to set up a mail server either locally or up on the cloud. and then you give it some kind of name. And they usually get clever names like mail. And then I could go ahead. It's not going to let me do this. Well, we'll see. Let me see if I hit OK. Yeah, it's not. It won't say. Isn't it fun to watch me type?
Absolutely. Well, I was going to ask a question while you're doing this. So doesn't the creation of the mail exchanger here also play into looking at the header of an email to authenticate whether the email actually came from the appropriate domain?
I'm going to actually, I am aware that that's part of it.
Yeah.
I'm better at getting the mail to you. I'm going to count on you to tell us how to use these tools to deal with that stuff. The last one I want to bring up, and this one's really important, is a text record. So you can see there's lots of records.
Definitely a lot of records, but the big ones I think that we hear about a lot of times, especially even in like interviews and so forth as well, are the A record and the pointer record. Those are absolutely asked a lot. And then just understanding DNS. And I think the deeper you can talk about DNS, the better understanding you have of it, the better it looks for that particular individual. But even just a 10,000 foot view in a lot of cases can be very beneficial to at least understand what's going on.
I agree. The only challenge I'm going to say to what you said is that a lot of times when I'm setting up security for email servers in particular, I'm required to add text records, and I type in a bunch of gobbledygook that I don't even know what half of it means, to be honest with you. It's the people who are, setting up the security say, oh, create a text record, call it Fred, and then put, all this type of information in. So this is a forward lookup zone with the type of records. And for Security Plus, you need to know all these. You need to know every one of these: SOA, NSA, quadruple A, CNAME, MX, and text. And as you saw, there's a lot more. All right. Let's talk about reverse lookup zones. A reverse lookup zone basically, if I have a fully qualified domain name, how can I set up, how can I figure out what the IP address is? So my network ID here is, oops. So what's my local network ID, which is 10.0.1 on this particular machine. And it wants it to do an active directory. Yeah, we finished. Okay, so what we've done here is we've created a reverse lookup zone. The one thing I want to mention about reverse lookup zones is that there's a lot of DNS servers out there that don't use it because reverse lookups are very rare. 99.99999 times out of 100, I have a fully qualified domain name. I need an IP address. So that's what the forward lookup zone does. Reverse lookup zones, remember, do the exact opposite. So
would this be where somebody actually types in the IP address in their browser as opposed to typing in the actual domain name?
No, actually, if you type the IP address in the browser, you're skipping DNS completely.
Oh, okay.
I mean, you're going straight to it. In fact, that's a terrible idea. The reason it's a terrible idea to type in an IP address, like especially on a big web server, is most web servers are supporting more than one website. And they actually need to see that www.whatwebsitedouyowanna.see.com in the request. And if you just type in the IP address, that web server is going to go, I don't know, I've got 4 different websites on here. I can't help you. Obviously, when we're typing in IP addresses for routers and stuff like that, we're just completely skipping the DNS. What reverse lookup zones are really important for is in a lot of spam checkers and things like this. They're like, wait a minute, is 10.0.1.45, is that really mail.cybernowlabs.com? And they'll use that reverse to look back and go, ha, caught you, Mr. Spammer. And so that's where reverse lookup zones really come into play. You'll notice on this system, I didn't even have a reverse lookup zone because this little DNS server is literally just handling my 14 computers, my 20 some odd IoT devices. You get the idea?
Yeah.
And what will happen is when my machine wants to find www.cybernowlabs.com, he will query that DNS server, Richard, but built into my DNS server, I've got what's called forwarder. In other words, DNS server, if you don't know how to resolve this, send it up. And that's actually connected to my upstream ISP.
Gotcha. I think most people generally just tend to rely on their upstream ISP DNS servers, right?
Well, I would challenge that a little bit. Like for example, I use a oh goodness sakes, what do you call it?
I'm probably talking more like personal at home. Like
yeah,
most people,
but even folks at home
DNS
should
server.
consider alternatives. Like for example, one thing you ought to consider is using one of these public super DNS servers, like good old 8.8.8.8, which is a Google DNS server. I'm not saying it has to be your primary one, but you ought to consider doing it as your secondary. There's some good reasons to do that. Number one, Richard, have you ever typed in www.goggle.com and you hit enter and all of a sudden you get this thing from AT&T or Xfinity saying, oh, you don't know what you're talking about. Yeah. Maybe you meant this. So what you're talking about is DNS creates kind of a walled garden for some of these folks where they're playing Big Brother and they can throw some ads in. I don't like that. So often I just don't want to use my ISPs for that reason. The other reason is I don't like advertising I don't need to watch. So I have a special little Raspberry Pi running in my house here called my Pi hole. And the Pi hole is basically pretending to be a DNS server. And really all it's doing is it knows all of the advertising companies and it just bit buckets those DNS requests. So when I fire up YouTube, for example, while you're watching that 60-second commercial, I don't watch it. Nice. Isn't that nice? So there are some, even in homes, there are some reasons to go beyond simply using your own ISP.
I love the Pi hole name. That's awesome.
It's a wonderful tool. Go for $30 for a Raspberry. Don't even buy the nice Raspberry Pi. Buy an old one and install Pi hole on there. And come on, you guys know what I'm talking about. People get so used to looking at ads. It just drives me crazy. If I can avoid them, I do. It's not a perfect tool, but it's close.
Absolutely. Well, listen, I know you could probably talk for a lot longer on DNS, but I think we should probably go ahead and chop it off for today. As always, your expertise is absolutely appreciated. And hopefully everybody that joined us today enjoyed that session on DNS. Continue to dive in, continue to dig into Security Plus topics. If you're getting into cybersecurity, absolutely paramount to be able to understand exactly how this stuff works so that you can not only understand it and talk about it, but use it every day when you're doing investigations. So thanks for joining us again, Mike. Till next time, bud. See ya.
Later, Tater.
If you like Two Bold Nerds, check out our entire playlist right here. It's a lot of fun. We'll see you there.